Have you ever been cruising along the freeway, glanced at a huge dump truck or concrete mixer rolling beside you, and realized something isn't right? You notice the enormous wheels rotating, the heavy chassis shaking, but when you focus on the tires, one complete set of them is floating above the asphalt. They're just suspended there, turning uselessly in midair, ghosting along without ever making contact. No, they're not spare tires. No, the suspension didn't give out. And no, you're not watching some weird glitch in reality. But that floating wheel isn't a malfunction. It is actually a brilliant piece of engineering that saves billions of dollars in road repairs, saves the trucking company a fortune in fuel, and stops the truck from destroying itself during a turn. Today, we're looking at the surprising reason why some truck tires are designed not to touch the ground, right here in CuriOddity. To understand the floating wheel, we first have to look at the road beneath it. Asphalt and concrete appear solid, but they can only handle so much pressure before they give way. When you concentrate excessive weight on one spot, you're not simply traveling across the surface, you're pulverizing it. That's why authorities impose rigid weight restrictions per axle. The issue isn't the truck's total mass, it's how that mass gets spread out. Think of it like a bed of nails. If you push a single nail into your hand, it punctures the skin easily. But lie on a bed of 1,000 nails, and your weight spreads across so many points that none of them break through. That's precisely the job of those additional wheels, officially known as a lift axle. So, if more wheels mean better weight distribution and safer roads, why not keep them down all the time? Why raise them back up? The answer, as is often the case in history, comes down to money. Tires cost a small fortune. Commercial truck tires run hundreds of dollars a piece, and they degrade fast. Every mile a tire spins against asphalt generates friction, what engineers call rolling resistance. The more rubber you have gripping the road, the more power the engine needs to move forward, and the more diesel you consume. Picture a truck that's just unloaded its cargo. It's now running empty and lightweight. If those bonus axles stay deployed, they're wasting fuel and grinding down costly rubber unnecessarily. Retracting them immediately cuts rolling resistance. It's essentially an eco mode for heavy machinery. Beyond that, there's the toll booth factor. Numerous highways and crossings bill trucks according to how many axles are making contact. By raising that spare set of wheels, a trucker can reclassify the vehicle as smaller, sometimes slashing the toll charge by half. There is one final crucial reason for the lift axle: maneuverability. Trucks are long. When a truck with several permanent axles attempts a sharp corner, the back wheels don't simply roll, they skid sideways across the surface. This is called scrubbing. It squeals, it demolishes the tires, and it creates enormous strain on the vehicle's chassis and suspension system. With too many wheels planted, the truck basically wants to keep going straight forever. It fights every turn. By retracting that bonus axle, the driver effectively reduces the truck's wheelbase. This lets the vehicle swing smoothly through corners, handling cramped job sites or urban intersections without shredding tire rubber or gouging the pavement. So the next time you see a truck with a ghost wheel hovering in the air, you'll know it's not broken. It's a shapeshifter. It's a machine adapting in real time, balancing the laws of physics with the laws of the road and the cost of doing business. I hope you enjoyed this slice of engineering history. If you did, please hit that like button and subscribe to CuriOddity for more stories about the everyday world around us. Thanks for watching.